This is exam review from Chapter 6. Chapter 6 was all about systems of equations as well as systems of inequalities. We're going to first go through all the highlights and then take a look at least one example of each type of problem that will be on your final exam. So first thing we did was to check to see if a solution works for a system of equations. In order to do that, you are going to take the solution that's given and you need to plug it into all equations. It is very important to note that in order to be a solution to a system, that solution must work for all of our equations. So if you're checking them and you get to the first one and it doesn't work in the first one, you can stop right there and say, no, it's not a solution. If it does work in the first one, you will need to check it in the second one as well. If it works in both, then yes, it is a solution. We learned 3 different ways to solve systems of equations. The first was by graphing. When we solve by graphing, we graph the 2 lines. Suppose our first line looks like that and our second line looks like this. We are looking for where those 2 lines intersect. So wherever they intersect, that's going to be our solution, that ordered pair. It is possible when we graph the 2 lines that we have parallel lines. My lines look like that, and they are never going to cross each other. When that's the case, we state that there is no solution. It is also possible that I graph the first line and it looks like that, and we graph the second line and it lines right up on top of the other one. I guess this one's not perfectly parallel. But if our 2 lines do line up right on top of each other, we have infinitely many solutions. So we can solve systems by graphing. We also solve them by substitution. The way substitution works is one of my equations is going to say y equals something, or a equals, or x equals, or b equals, or one of the equations will say something equals something else. What we are going to do then is take whatever y is equal to and substitute it, plug it in for the y in the other equation. Now we just have one variable and we can solve from there. That is solving by substitution. The third and final way that we learned to solve systems of equations was by elimination. To do elimination, we want to add the 2 equations together so that one of the variables cancels out. So if I have something like this, I add my 2 equations together. My 4y minus 4y, I want to cancel. 4y minus 4y cancels, so I add my equations together, solve for x, and then plug back in to get y. Now sometimes we are unable to add the equations together right from the start. So I have something like 2x minus 2y equals 5. And I need to think about, okay, this one's 4y, so this one needs to be negative 4y, so I have to multiply this whole equation by 2. And then I can add the equations together, and we'll take a look at an example like that in a minute. And then the final thing from this chapter was graphing inequalities or systems of inequalities. To graph an inequality, things to remember are sometimes we have dashed lines, sometimes we have solid lines. If we have a less than or a greater than, but not the or equal to under it, that is when we use a dashed line. If it's less than or equal to or greater than or equal to, we have our solid line. And then we also need to figure out which way to shade. If it says y is greater than something, y is greater than the line, we want the y values above the line, we shade above. If it says y is less than something, that is when we shade below. If x and y are on the same side, we either need to solve for y so that we can use this method, or the other way we can do it is choose a test point. So if x and y are on the same side, we're going to solve for y, and then we can do it this way, or our other option is to use a test point. And we'll talk through that in a minute as well. So again, every example that we're getting ready to do has a similar problem on your final exam. I would make sure I know how to do these so that you're ready to go for the exam here in a couple weeks. Number 9, we did numbers 1 through 8 last time. Number 9 asks us, is the point -2, 4 a solution to the system of equations below? We are asked to show all the required work, but we do not have to solve the system. We are just checking if the solution works. So is -2, 4, remember our first value here is our x value and our second is our y. Is that a solution? So we need it to work in both of our equations. So I'm going to plug -2 in for my x. So it says negative x. X is -2 plus 2 times y. Y is 4 equals 10. -2 minus next to each other becomes positive. +2 times +4 is 8. 2 plus 8 does indeed give us 10. It does work in this first equation. That is not enough to say that it is a solution. It's a solution to the first equation. We need to see, is it a solution to the second equation? In order to be a solution in the system, it has to work in both. So when I plug in the point into our second equation, it says 7 times -2 plus 5 times 4 equals -8. 7 times -2 is -14. 5 times 4 is 20. -14 plus 20 does not give me -8. It does not work in our second equation, therefore, no, it is not a solution to the system. Question number 10 asks us to solve this system by graphing. Solve by graphing. To solve by graphing, we graph the two lines and we see where those two lines cross. It's possible they don't cross. If they don't cross, we have no solution. So we start with this first one, y equals x plus 6. Remember, if there's no number written out front there, our coefficient is understood to be a 1. So we know our slope is 1 and our y-intercept is 6. We always graph the y-intercept first. So we need a y-intercept of 6. And a slope of 1. If the slope is 1, slope, remember, is rise over run. 1 over 1, so I need to go up 1, right 1. Up 1, right 1, up 1, right 1. To continue on that line, I'm going to go down 1, left 1. Notice those points are also on that same line. And we are going to fill up the whole graph lots of points, because we need to find exactly where those two lines cross. If I just graph a couple lines and then just sketch it in, it's kind of hard to tell if the solution's over here somewhere. So we've got our first line. The second line, y-intercept is -2, and the slope is -3. That's down 3 over 1. Looks like it's going to cross over here somewhere. Let's continue to go up 3 and left 1, and note that those are on the same line. We can graph that line in. And hopefully we can recognize that those two lines cross at this point right here. That is our solution. Make sure that we write out our solution. That is the point. -2 is my x. 1, 2, 3, 4 is my y. -2, 4. Number 11. Number 11 asks us to solve the system of equations by substitution. Solve by substitution. Y equals 6x minus 2. And 4x minus y equals 10. Y equals 6x minus 2. 4x minus y is equal to 10. For substitution, we have an equation that says y equals something. So I'm going to take what y is equal to, and I'm going to, in the other equation, replace the y with what it's equal to. So this equation would say 4x minus, and instead of y, I'm putting in 6x minus 2 equals 10. We are replacing y with the 6x minus 2. Anytime I substitute something in, I put it in parentheses here. That's important. This 4x, I'm just copying down here, and I am distributing this negative sign. So I've got minus 6x and minus negative 2. Minus negative 2 turns into plus 2. Combine up any like terms we have. This 4x minus 6x is on the same side, so I can combine them. 4x is minus 2x, or 6x's, I have negative 2x's. And we are down to a two-step equation that we should be able to solve. Subtract 2 from both sides. Negative 2x equals 8. And divide by both sides by negative 2. I get x equals negative 4. Remember, a solution to our system, it has both an x and a y value. It has an x and a y value. We got the x value here. We need to get the y value. We get the y value by going back to one of the original equations, either one, doesn't matter which one, although the one that says y equals is generally going to be easier to work with. And we replace the x with negative 4. So I've got y equals 6x minus 2, 6 times x minus 2, but instead of x, I'm putting in negative 4 for my x. 6 times negative 4 is negative 24, minus 2, my y value is negative 26. Question number 12, again, asks us to solve a system of equations. This time we are solving it by elimination. Solve the system of equations by elimination. We have 4a minus 3b equals 11, and 2a plus 5b equals negative 1. 4a minus 3b equals 11, 2a plus 5b equals negative 1. First thing we need to do is decide which variable we're going to eliminate. Notice if I add the equations together right now, I've got 6a, I've got 2b, nothing eliminates. So looking at the b's, 5 and 3, I could make those both 15, but I'd have to multiply this equation by 5 and this one by 3. 4 and 2 are going to be much easier to work with. So this one's positive 4a. I want this one to be minus 4a. That way, when I add them together, they cancel. So to make this minus 4a, I need to multiply this equation times negative 2. So my top equation, I didn't change. 4a minus 3b equals 11. The bottom equation, I'm multiplying everything times negative 2. 2a times negative 2. 5b times negative 2. And negative 1 times negative 2. Negative times negative is positive. And now I can add my two equations together. 4a minus 4a cancels. Negative 3b minus 10b is negative 13b. 11 plus 2 is 13. Divide both sides by negative 13 to get b by itself. And we get down to b equals negative 1. Just like the previous problem, I have one variable. I need to get the other one. We know b is negative 1, so I can substitute negative 1 back into either equation and get a. Again, doesn't matter which one you choose. I'm going to go with the top one. I've got 4a minus 3 times b equals 11. But instead of b, I'm putting in what it's equal to. Negative 3 times negative 1 is positive 3. And solve for b. I'm sorry, solve for a. I get A equals 2. A equals 2, B equals -1. Number 13. Number 13 is a story problem. It tells us that we only need to set up a system. We don't have to solve it. It says at a restaurant, the cost of a hamburger and a small order of fries is $6.97. The cost for 3 hamburgers and 4 small orders of fries is $16.93. We are asked to set up a system of equations that, when solved, finds the price of a hamburger and the price of a small order of fries. So the first thing we know is if I buy 1 hamburger and 1 order of fries, it costs $6.97. Notice it tells us to call hamburger H and order of fries F. Also, if we buy 3 hamburgers and 4 orders of fries, it costs $16.93. That is our system of equations. We are not required to solve it. We just need to set it up. And number 14 asks us to show the solution to the inequality 4x minus 2y is less than 12. 4x minus 2y is less than 12. There are a couple different ways you could do this problem. The way I'm going to do it, at least the first time, is by finding the x-intercept and the y-intercept. To get the x-intercept, we put in 0 for the y. So if I put in 0 for the y, the point on the line says 4x equals 12. Because I'm looking for the points on the line, we're using the equal sign instead of this inequality. We'll talk about what to do with that inequality in a minute. Dividing both sides by 4, I get x equals 3. My x-intercept is 3. It needs to cross the x-axis at 3. Y-intercept, we do the same thing, but we put in 0 for our x. Gives me -2y equals 12. And I get y equals -6. 1, 2, 3, 4, 5, 6. So we have 2 points. 2 points is enough to draw a line. Because it's less than but not equal to, we know we have a dashed line. So we should have a dashed line that passes through those 2 points. And to figure out which way to shade, because x and y are on the same side, we're going to use a test point. The easiest test point to choose is 0, 0. The only time you can't use 0, 0 is if the line goes through that point. So if I put in 0 for x and 0 for y, I get 0 is less than 12, which is a true statement, which means I need to shade in 0, 0. And it's on this side, which means this side here is the side that gets shaded. If you understood that way to do it, great. If not, there is a different way we could do this problem. Instead of finding the x and the y-intercepts, we could change to slope-intercept form. So the equation as written says 4x minus 2y is less than 12. We could subtract 4x from both sides. So I get -4x plus 12. And then divide both sides by -2. Negative divided by negative is positive 2x. 12 divided by -2 is -6. Don't forget, when I divide by a negative, we need to flip our inequality around. So our y-intercept is -6. Our slope is 2, up 2 over 1. Notice that gives me that same line. You'd have all those points. Your line is still dashed. And then it says y is greater than the line. I want the y values above the line, which shades in the same ones. So either way you do it, you should get exactly the same graph, whichever way whichever way makes more sense for you would be the way to go. That is it for Chapter 6. We will continue with Chapter 7, exam review, next class.